everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class, and that is being the class is your 14th class of the session here. And in the last classes we had done your 13th classes where we had started with unit 1, that is being the name is your computer arithmetic errors and rules of equation. So in this we had done many of the questions related to the bisection method, secant method, and even though we had started with Newton-Raphson method as well, regular Farsi method we had completed too. In regular your this method, which has been the Newton-Raphson method, we have to cover up, and we had done even the formulas in the last classes. If you had not visited that, you can go ahead, we will find it out each and every video there. Before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. In same cases, we go ahead here, and that has been the first question of the session. Find the smallest positive roots of the equation e to the power minus x is equals to sine x using Newton's Raphson method and our method, taking initial value of x0 is equals to 0 itself. So we go ahead. Find the smallest positive roots of the equation e to the power minus x is equals to sine x using Newton-Raphson method, taking initial value x0 is equals to 0. So we go ahead. Xn plus 1 is equals to xn minus fxn upon f dash xn. Newton-Raphson method formula we will apply here. So here fx is equals to e to the power minus x minus sine x is equals to 0. F dash x is equals to minus e to the power minus x minus cos x. Xn plus 1 is equals to xn minus e to the power xn minus sine xn upon minus e to the power minus xn minus cos xn. Now we talk about for iteration 1. So for iteration 1 it will be x1 is equals to x0 minus fx0 upon fx0 f dash x0, which is equals to x0 minus e to the power minus x0 minus sine x0 upon minus e to the power minus x0 minus cos x0 equals to 0 minus e to the power minus 0 minus sine 0 whole upon minus e to the power minus 0 minus cos 0, that is equals to 0.5. Now for iteration 2 we go ahead, and that is what we have to talk about it. So for that, so for iteration 2, x2 is equals to x1 minus fx1 upon f dash x1 equals to 0.5 minus e to the power minus 0.5 minus sine 0.5 upon minus e to the power minus 0.5 minus cos 0.5 equals to 0.5 minus 0.127105 upon minus 1.484113 equals to 0.585644. That is being 0.5 here. For iteration third, and for iteration 4. So for first we'll find out for the iteration third here. x3 is equals to x2 minus fx2 upon f dash x2 equals to 0.585644 minus 0.004011 upon minus 1.390104, and which is equals to 0.588529. So 0.58 we have here. For iteration 4, talking about that is we have x4 is equals to x3 minus fx3 upon f dash x3 equals to 0.588592 minus 0.000005 upon 1.386901, and that will give 0.5885, which we have 33. So here you have to note that the smallest positive value is 0, and we started the iterations of the method from 0. Finally we obtain x4, which equals to 0.58853, and hence this is the smallest positive root. It is correct up to 4 decimal places as well. We'll go ahead for the next question. That has been of course important one, and that what we even do have to talk about it. And so that let's go ahead for the next question of using Newton-Raphson method. The question is, find the root of the equation x4 plus 12x plus 7 is equals to 0 lying between, that is lying between minus 2 and minus 3, correct to 4 places of decimals using Newton-Raphson method. So we go ahead for the same. Here fx is equals to x to the power 4 plus 12x plus 7 is equals to 0. F dash x is equals to 4x to the power 3 plus 12, and f double dash x is equals to 12x. So you have to note that Newton-Raphson method requires only one value, which is of x0 iteration, so that the roots in the interval minus 2 and minus 3, we have to select minus 2 or minus 3 better conversions. The value for x0 should be selected, such as fx 0, f double dash x 0 is greater than 0 here. So let us check the following values here for the same. Minus 2 to the power 4 plus 12 minus 2 plus 7 is equals to minus 1, and for f minus 3 is equals to minus 3 to the power whole 4 plus 12 multiply minus 3 plus 7, so that is equals to 52. F double dash 2 minus 2 equals to 12 minus 2 equals to minus 24, and f double dash minus 3 is equals to 12 minus 3 equals to minus 56. If minus 2 into f double dash minus 2 is greater than 0 and f minus 3 f double dash minus 3 is less than 0, so we take here that is x is equals to minus 2 as an initial approximation. So for iteration 1 we go ahead here, and that what we even though have to talk about it. x1 is equals to x0 minus fx0 upon f dash x0, which is equals to x0 minus x04 plus 12x0 plus 7 upon 4x0 to the power cube plus 12. So for the same we go ahead further, which has been minus 2 minus 2 power 4 plus 12 minus 2 plus 7 upon 4 minus 2 to the power 2 cube plus 12 is equals to minus 2.05. Now for iteration 2 we talk about it, that what we have to discussed here. For iteration 2, it is x2 minus x1 is minus fx1 upon f dash x1 equals to minus 2.05 minus 0.061006 upon minus 22.400500, and that is equals to minus 2.047284. So 2.0 we take it here. Now here that in successive iterations we go ahead, and for the same, that is your in successive iteration for the values of fx0 and fx1 and fx2, that will go on reducing. So we'll go ahead for iteration number 3. For that, x3 is equals to x2 minus fx, that is 2 upon f dash x2. We put the value minus 2.0472x484 minus 0.000186 upon minus 22.323706. It will give you the answer here is minus 2.047276, so minus 0.0472 it will be exceeding here. For that, here the values of the roots that repeats up to 4 decimal places in the third iteration, and so here hence that is being equals to the x equals to minus 2.047276 is the not as the root that correct up to 4 decimal places here. We go ahead for the next question, that has been the another important one, and that what we will have to discuss here, which is being another important question using Newton-Raphson method. The question is, find the negative real root of the equation x square plus 4 sine x is equals to 0, correct up to the 4 decimal places using the Newton-Raphson method here, and that what we will have to discuss here. Let's find it out for the same, and that is being important too. So we go ahead for the same, and that what we have to discuss here. Find the negative real root of the equation x2 plus 4 sine x equals to 0. Correct up to 4 decimal places using Newton-Raphson method. So we go ahead for that. Let us try the following negative values of x to establish the intervals in such a root lies. So for that it has been fx equals to x square plus 4 sine x is equals to 0. Okay, so for that, where f1 minus 1.5 equals to minus 1.739. For the next is f minus 0.2 equals to minus 0.754. F minus 1.8 equals to minus 0.0655. F 0 minus 0.7 is equals to minus 2.08. F1 point minus that is being we had done 0.7 minus 2.08 here, 0.7 we had done, minus 1.8 we had done, 0.2 minus 0.3 we had done, 0.7 we have here, sorry, not 3, 0.7 minus 0.7 we have, so that is being 0.0, 2.08 here, 2 minus 2.0 here, it will give my 0.3628, and f minus 1.0 is equals to minus 2.365 here that we have. Okay, now here we have your minus 1.8 multiply f minus 2.0 less than 0. So hence root lies between minus 1.8 and minus 2.0 here. So for that, f dash x is equals to 2x plus 4 cos x, and f double dash x is equals to 2 minus 4 sin x. F double dash 1 minus 1.8 equals to 5.895, and f double dash minus 2.0 is equals to 5.637. F 1.3 that is we have here, that is for the same, and that what we will have to discuss here. So with the same cases we go ahead, and for that we'll have to find it out here, and for 1.3 we go ahead here as well. So with the same cases that what we have to discuss here, and which is just to be as follows, that what f dash 1.8 we had find it out for the same, then 2.0 and then 1.0 we have to find out here. And for the after talking about 1.0 as well, we had find it for 2.0, then minus 1.8, and of course that what we have to discuss, and now we'll discuss about minus 1.8, and which is equals to the condition we have f of minus 1.8, f double dash minus 1.8 is less than 0, and f minus 2.0, f double dash to minus 2.0 is greater than 0. So here take x 0 is equals to minus 2.0, since f minus 2.0 and f double dash minus 2.0 is greater than 0, so this lies better conversions Newton-Raphson method formula for the given here. The formula we have xn plus 1 equals to xn minus f xn upon f dash xn. We'll put for the value here, that what we will have to discuss. For iteration 1, for that we go ahead, that what we have to discuss here. So x1 is equals to x0 equal minus fx0 upon f dash x0, which is equals to minus 2.0 minus f of minus 2.0 upon f of dash of minus 2.0 equals to minus 1.935951. Now for iteration 2 we go ahead. For iteration 2 it will be x2 is equals to x1 minus fx1 upon fx2 minus 1.935951 minus f of minus 1.935951 upon f of minus 1.935951, which is equals to 1.933756 we have. For iteration 3 we go ahead here, and that is what we will have to talk about it. So for iteration 3, so we go ahead, x3 is equals to x2 minus fx2 upon fx2 dash, which is equals to minus 1.933756 minus f minus 1.93375556 upon f dash minus 1.933756 is equals to that we have here, which has been minus 1.933756 here, that we have here. So for that, that's the root we have. X is equals to x3 equals to minus 1.933754. That is correct up to 5 decimal places here. Now we go ahead for the next question here. That is what we have to talk about it. Using Newton-Raphson method, solve the equation that we have. We go ahead for the next question here, that is being another important question. Using the Newton-Raphson method, solve the equation. Solve the equation. Fx equals to x minus x equals to 0, correct up to 5 significant digit after decimal point. So we go ahead, let us take x0 is equals to 0.5. So for iteration 1, x1 is equals to x0 minus fx0 upon f dash x0, 0.5 minus 0.106531 upon 1.606531 is equals to 0.566311. For iteration 2 we go ahead. x2 is equals to x1 minus fx1 upon f dash x1 will have value minus 0.106531 upon 1.606531 is equals to 0.566311. For sorry that for here it will be value 0.56. We have to minus half 0.566311 minus 0.001305 upon minus 1.1567616 0.56. We'll have another question is iteration 3. Iteration 3. x3 is equals to x2 minus fx2 upon f dash x2 here, and that is being 0.567143 minus 0.0000002686 upon 1.567143, which is equals to 0.567143. So here observe that x2 is equals to 0.567143 and x3 is equals to 0.567143. So we hear that the approximate value that we have will be the root 0.567143, that is correct up to 6 digit of the decimals here, and that what we will have to discuss as well. So we'll discuss the rest of the question in the next coming class here, and that is being important for all of you, and that is we'll discuss about the next coming class in the next classes here, and which has been important. Other than CBNST, we had done your sociology and software engineering, we had done your chemistry, where we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 with their conversions, logarithms and logs as well. And after talking about that, we had done understanding the human being comprehensively, the human aspiration and its fulfillment. In that we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, that is of 2 marks possible questions as well. We are dealing with ER diagram, we are dealing with English vocabulary, and we had done your reasoning, where in that we had done your verbal reasoning. In that we had done operation gender mental ability and the logic reasoning. In non-verbal reasoning we had done your series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical cubes and dice, dot situation, problems on numbers, and that figure matrix, figure formation analysis, and practice question set. In terms of quantitative aptitude, we had started with arithmetical ability. We had done your operations on numbers, as safe and LCM of number, decimal fractions, simplification, square roots and cube roots, problems on numbers, prompts on ages, starts and indices, percentage, and profit and loss. We are dealing with 11 topics. In terms of CBNST, which has been the computer-based numerical and statistical technique, in that we had done unit 1, which has been the computer arithmetic errors. Here in that we had covered up the floating point arithmetic machine, epsilon rounds of error, chopping error, truncation error, associative and distributive law, floating point arithmetic inherent error, error propagation, numerical instability, root of equation, second method, Newton-Raphson method, and the fixed point iteration method of simple roots, and derivation of their rate of the convergence, articles, accelerations of convergence, modified Newton-Raphson method to the multiple root, Bridge-White method for the polynomial, and Weierstrass method for the quadratic factor, that is computer algorithm of these methods as well. In unit 2 we have to cover the interpolation. In interpolation we have to cover the algorithms and the inner analysis of the Lagrangian, the Newton's dividend differences, interpolation, relationship in the variance differences, operation piecewise, your linear interpolation, cubic spline interpolation, natural spline, and Chebyshev's polynomial approximation, Langkow's economization of the power series, curve fitting. In that we have to cover up the linear, non-linear, least square approximation. Third, conditioning in the least square method. Gram-Schmidt's process of the orthogonalization composite algorithm of least square curve fitting. Unit third, we have to cover up the differentiation and integration. In differentiation, we have to cover up the methods based on the interpolation and finite differences, Richardson extrapolation. In integration, we have to cover up the error analysis of the trapezoidal Simpson method, Newton cos integration method, Gaussian integration method, Gauss-Legrand method, Lobato integration method, and the Radau integration method. Error terms in the integration method as well. After talk about that, in unit 4 we have to cover the solution of simultaneous algebraic equation. That we have to cover the Gauss elimination method, conditional system, condition number, successive and the Raphson methods, rate of convergence, solutions of ordinary differential equation, single step method, Nagiota method, second order, third order, and the fourth order method, multi-step method, predictor, corrective method, statistical techniques, statistical hypothesis, test of hypothesis, step 1, type 2, errors, level of significance test involving normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.